Namaskar. Let's solve one more problem from simultaneous differential equation. I have already covered two problems. This type of problem are a bit lengthy, so you must focus on each and every step of this problem. So to start with, as you can see, both x and y is here. Okay, and d by dt is there. So one thing for sure, that your d by dt is going to be your capital D for this problem. So if you write this in operator form or in the terms of d, you can write d, because d is d by dt, fine, plus 4 x plus 3y equals to t as your first equation, and likewise your second one will be d plus 5, because I am deciding to take 5 y common, okay, plus 2x equals to e power t. Now you have to eliminate either x or y from here, from both the equation. So let's suppose I'm going to eliminate y. I can't so by eliminating both, because it can be even more lengthier than in that case. You can do that yourself. But let's suppose I'm going to eliminate y. So in order to eliminate y, the coefficient of y in both the equation needs to be equal. So if I want the coefficient to be equal, in the first equation the coefficient of y is 3. In the second equation the coefficient of y is d plus 5. So one thing for sure, I will have to multiply the second by 3, and I will have to operate the first by d plus 5. This I will have to operate by d plus 5. Fine. I hope you know what is meaning of operate by. You will have to just like let's say you have some equation like this, x square plus 4 equals to 7x. If I differentiate both sides with respect to x, this is something called operating both sides. Okay, so both sides I will differentiate with respect to x. I am doing the similar thing here. Okay, so if I do so, then the coefficient of y will be same. Fine, so let's do that. So my first equation will become d plus 5 d plus 4 x plus 3 times d plus 5 operating on y, d plus 5 operating on t. In the second equation I am just multiplying by 3, so better to write it below this. So 3 d plus 5 y, and I am writing 6x here below this. Fine. And d plus 3 times e power t. Now what I will have to do, I will have to simply subtract this. So this will get eliminated. This was my dream, to eliminate this. Now what's next? Just simplify. So d plus 5 d plus 4. So let's open the brackets. So this will become d square or d2, whatever you say, second derivative, plus 4d plus 5d. So I am straight away writing 9d to save some time and space as well. That was 4d plus 5d is 9d, plus 20 operating on x. Okay, this is LHS, And what else I have in LHS? I have minus 6x. In RHS, I have d plus 5t. Okay. So because d is nothing but d by dt, as I mentioned earlier only. So d, this is nothing but d plus 5t if I am saying. So that is nothing but d by dt. So if I operate this, so this will be dt by dt. This is nothing but 1 plus 5t. Fine. Minus 3e power t. Further, what I can do, I can simplify this by taking x common or operating on x. So this is d2 plus 9d. 20 minus 6 is 14. Operating on x equals to 1 plus 5t minus 3e power t. Now this becomes a brand new problem for you to solve. Okay, so here as you can see, your dependent variable will be x, your independent variable will be t. This is important to write so that you don't make mistake while applying the formula. So now if I find my auxiliary equation, so that will be, just replace capital D by m. So m square plus 9m plus 14. This is what you are getting from the bracket. Equate it to 0. Fine. So if I need 14, I can write this as 7m plus 2m plus 14 equals to 0. So I can write this as taking m common, m plus, I am slow in factorization. Next, what we can do, you can just take m plus 7 and m plus 2 equals to 0. So from here you are getting two values of m. One is minus 7 and the other is minus 2. So I can now write my complementary function. You must have your dependent and independent variable in mind. So in complementary function, basically dependent variable comes or independent variable comes. So this will be C1 because real and distinct. So C1 e power. Because there also you problem like this, d square plus 4y equals to something. You used to take C1 e power x because x would have been the independent variable in that case. Okay, so independent variable comes in complementary function. So e power minus 70 e power mx would have been there. So e power, because here I hope you know t is the independent variable, so in place of x it will t will come. So plus second constant e power minus 2. I hope it's clear to you. What about particular integral? That will be 1 upon f of d. What is f of d? That is d square plus 9d plus 14. And this is operating on your RHS. And what is your RHS? RHS is 1 plus 5t minus 3 e power t. Now you can break this now into 3 pieces, 3 parts, so that you can solve it easily. So 1 is nothing but e power 0 t. Fine. So 1 upon d square plus 9d plus 14 operating on e power 0 t plus 5 I can take out, 1 upon d2 plus 9d plus 14 operating on t, 5 I have already taken out, 3 1 upon d square plus 9d plus 14 operating on e power t. First and the third one is going to be very easy for you, similar of its kind. You just replace capital D by a. A is just the coefficient of t. Okay, so your particular integral is, if you replace d by 0 in this case, so 0 0, so just you are getting 1 by 14. So first part is solved very easily. And in second part again, if it is some t, this is some power of t here, so we'll have to solve it bit carefully. What we'll do, you will take the lowest power common. So 14 if I take common, I will get 1 in place of 14 and d square plus 9d by 14 as the second. This will operate on t minus 3. And what about this? Coefficient of t in this case is 1. So replace d by 1. So 1 square plus 9. So that is 10. 10 plus 14. I'm just replacing d by 1. So 1 plus 9. 10. 10 plus 14 is 24. This is also solved. And I'm again, to save some steps, I am writing it as 1 by 8. Fine. So here in the first part, writing e power 0 t again. Here if I write also e power 0 t, that doesn't matter because that is 1 only. But here I need to write e power t. What's next? Particular integral is 1 by 14. Now here this 5 by 14 can be written like this, and this entire thing can go up as 1 plus d square plus 9d by 14 power minus 1 operating on t. Now this is playing the role of 1. This is playing the role of x. So this is nothing but 1 plus x power minus 1. And what is the expansion for that? So 1 plus x power minus 1 is 1 minus x plus x square minus x cube, alternate plus minus, plus x power 4 and so on. The important thing to take care is we don't need to expand it completely, because first derivative of t is 1, second derivative onwards it is 0. So only till you see here, only till if first two terms only if you calculate, then also it will be sufficient, because this onwards it will become 0. So we only need to expand till second term, and this is 1 minus 1 by 8 e power t. So your particular integral is 1 by 14 plus 5 by 14. Now this is 1, and as I told you, this is the playing the role of x. So 1 minus x, so minus d2 plus 9d by 14. I would have written plus x square, plus that doesn't matter because that will contain terms like d power 4 and 9d 81d squared, something like that. Everything will become 0. Okay, minimum power, as you can see, will be 2 only here. Okay, so that clarifies that second derivative, because it's 0, no need to write it, so you can just write plus dot 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 dot. operating on t, minus 1 by 8 e power t stays there. Now let's solve it further. So 1 by 14 plus what to do next? 5 by 14 multiplied by 1 and multiplied by t. So I am writing it as 5 by 14t, and then minus of, again, second derivative, if I write it separately, minus 9 times the first derivative and operating on t, minus 1 by 8 e power t. So particular integral is 1 by 14 plus 5 by 14t. Second derivative, as I told, d is d by dt. So d by dt of t is 1, and if you do again derivative, so derivative of 1 is 0. So this will give you 0. I am not writing that. First derivative of t is 1. So from here you will get 9 by 14. And from here you will get minus 1 by 8 e power t. Fine. So if I were to collect terms from here, I will get my particular integral as 5 by 14 t minus 8 by 14 is minus 4 by 7 as a constant, and minus 1 by 8 e power t. So finally your x will be cf plus pi. So what was the cf long way back, c1 e power minus 7 and minus 2. Okay, so c1 e power minus 7t plus c2 e power minus 2t, and this is your pi, which is 5 by 14t minus 4 by 7 minus 1 by 8 e power. So let's do some matching, because this is a very critical problem, so each and every step is vulnerable to mistakes. So while calculating pi, this is fine, 1 by 14 and 5 by 14 multiplied by 1 multiplied by t, and here I did a bit of a mistake. I missed 5 by 14 to be multiplied by this and then operated with t. So I will have to write 5 by 14 here. No way 5 by 14 if I write here. So this will be 5 by 14 into 14 is 196, and 5 by 14 if I multiply here, so 45 by 196. Fine. Now in next step, this anyway is going to become 0, and what about this one, 45 by 196. Okay, so if I were to cancel it out, so I will get 45 by 196 here. 45 by 196 can be cancelled, I think. $45 . 45 by 196 is to be written here. Fine. So when it comes to the constant term, I will have this 2. So this will be nothing but 1 by 14 minus 45 by 196. So 196 if I take, it will be 14 here and minus 45. So it will be minus of 31 by 196. So bit of messy calculations here. Minus 31 by 196. So 5 by 14t is fine, and here I will have to make some change, that is minus 31 by 196 and minus 1 by 8 e power. So this is done. Now what we'll have to do, we have successfully found, now find the value of x. So with the help of this x value and the equations which we found earlier, which was this equation, if you focus on equation number 1, from equation number 1 can I write this, because I have now got x, I want y, so I can find using this equation. Y from here will be minus of d plus 4 operating on x, rather like this, 1 by 3 t minus d plus 4 operating on x. I can write like this in order to find y. So let's find y first. So 1 by 3 t minus d plus 4x. Y बराबर 1 by 3 t minus d plus 4 operating on x. Okay, this can be a bit lengthy from here. So 1 by 3 t minus d of x minus 4 times x. So everywhere we need to put the value of, in every, not everywhere, in the second and the third term. So 1 by 3 t minus d of x means d by dt. D is nothing but d by dt, and I will have to write complete x here. So it's bit lengthy, as you can see. I will have to write the complete x here, which is c1 e power minus 7t plus c2 e power minus 2t plus 5 by 14t minus 31 by 196 minus 1 by 8 e part. It's lengthy. And minus 4 times this x, so minus 4 times this x, so just multiply minus 4 by this, okay, in every term, so that we don't need to do it again and again. Okay, so if in the first term if you multiply, so you'll get minus 4 c1 e power minus 7t. In the second term if you multiply minus 4, so minus 4 c2 e power minus 2t. Fine. In the third term if you multiply minus 4, so that will be minus 20 by 14, so minus 10 by 70, and then it becomes minus plus 31 by 49, cancelling it 4, then it will become minus plus again, it will be 1 by 2. So your y is 1 by 3t. Now if you differentiate c1 e power minus 7t, so this will be you will have to just because you are differentiating, so you'll have to multiply by extra minus 7 by chain rule, which will be become plus 7 because one minus sign I will have here. So this will simply be 7 c1 e power minus 7. I hope it's fine. In similar fashion, next one will be 2 will come out because minus is already there, so minus 2 into minus 1, so this will be 2 c2 e power minus 2t, and then derivative of t is 1, so simply you will get minus 5 by 14. This constant term derivative will go, e power t derivative is e power t only, and minus minus plus, so 1 by 8 e power t, and the rest terms as it is to be copied. So minus 4 c1 e power minus 70 minus 4 c2 e power minus 2t minus 10 by 7t plus 31 by 49 plus 1 by 2 e power t. So let's collect the common terms from here. So I will have, when it comes to t, we have 1 minus when it comes to t, so 1 by 3 minus 10 by 7. uh, 1 by 3 minus 10 by 7. Fine. So this will nothing be but 21. So 7 minus, this is nothing but 3, so 30. So this is minus of 23 by 21. Fine. You have to say it again. 21 is to be multiplied by 7. This is to be multiplied by 3. So 7 minus 30 is minus 23 by 21. Then terms with e power minus 70. So you have 7 here minus 4 here, so just 3 c1 e power minus 70. Then you have terms with e power minus 2t, so you have 2 here and minus 4 here, so minus 2 c2 e power minus 2t. Then it comes to the constant terms, and the constant term we are having is 5 by 14 minus 5 by 14 and 31 by 49. So 31 by 49 minus 5 by 14. So this is if I take LCM, so 49 will be 80 and 9 to 98. 62 minus 35. 5 to 7 and 20. 7 by 98. and when it comes to e power t, so 1 by 8 plus 1 by 2. So 1 by 8 plus 1 by 2. This is 1 plus 4 by 5 by 8 e power t. So this is the complete thing. If you see, uh, coefficient of t in this case. Okay, here I have done one more mistake which I clarified now. So while doing the calculation, this 1 by 3 which was there, this 1 by 3, I just divided by t, but I didn't divide it by the other terms. So for the time being, let's keep this 3 with y only. Okay, so let's remain this as 3y. Okay, so only this will not be there, and in that case this will just be 3y, 3y, and simply t. Fine. Now what I can do is this t minus 10 by 7 t. So t minus 10 by 70 is minus 3 by 70. Rest every terms is fine. Minus 3 by 70. Then this is fine. This is fine. This is fine. This is so. Now what I can do, I can simply divide by 3 both sides. So y equals to, if I divide by 3, so this will simply be minus 1 by 70 plus c1 e power minus 70 and minus 2 by 3 c2 e power minus 2t. 27 by 3 is 9, so this will be 9 by 98, the constant term. And at last this will be 5 by 24. So minus 2 by 3 c2 e power minus 2t, c2, okay, c1 e power minus 70, minus 1 by 70, 9 by 98, and 5 by 24 e power. So this is y. So we have now found y, we have now found x. What's next is our solution. So we needed to find the value of x and y from here, which we have successfully found out. It was a bit lengthy, just frustrated with calculations a bit in the last stage of the problem, but yes, if you focus on the previous steps, that was not that difficult. Just I missed that 1 by 3, which made me lose quite bit of time. But yes, you have got your x, you have got your y. Your x was this, which was c1 e power minus 7t and c2 e power minus 2t whatever, and then you have finally found the value of y, which is this. So this was the goal of our problem. If I were to recapitulate this, the problem looks smaller to you now. We have to write this in this form, capital D. Now in order to eliminate y, we have to operate first by d plus 5 and second we have to multiply by 3 so that y gets eliminated. Then you get a simple problem. Here your capital D was nothing but d by dt. As I told, dependent variable was x, independent variable was t, and rest was a similar auxiliary equation, then complementary function, then particular integral. In particular integral also the middle one was a bit lengthy, not that difficult, 1 plus x power minus 1 expansion. And then we found the particular integral. There also I was stuck a bit in calculation, but yes. Then we went back to the first equation, and from there y was this. Better take 3y, and then later we divided by 3 on both sides because calculation will be easier in that case. And then just divide by 3 on both the side, and there you get y. Okay. So in the last stage, what we have to do is we have to simply use that equation as you can see here, this equation. Here you put the value of x which you have obtained and just differentiate. The value of x was in terms of t, so differentiate it with respect to t. Anyway, d was d by dt, so we have to differentiate with respect to t only, and multiply by 4x, and then there you get y, divide by 3 both sides. So I took a lot of time in this problem, but yes, with the practice it will go on. I have already solved 2 problems in this simultaneous differential equation. You can go and watch that in the playlist ordinary differential equation. Thanks again.